Whenever we're sailing in tidal waters, or where there is a significant current and we wish to navigate efficiently across the stream, we need to offset our course into the tide. If our destination is within sight and we believe that the set and drift will be relatively constant over the duration of our passage, we can do this very simply by adjusting the course we are steering such that our destination remains on a constant bearing. If the bearing to our destination increases, we need to turn to starboard. If it decreases, we turn to port. If we can't see our destination, we can accomplish exactly the same result by entering it as a waypoint into our GPS and making it the active waypoint. Then we gradually adjust our heading such that our course over the ground, COG, equals the bearing to waypoint, BTW. If your COG is less than BTW, and in this instance, if you think about it, 356 is less than 009, you gradually turn to starboard. And if your COG is greater than BTW, gradually turn to port. Again, in this example, 037 is greater than 356. You also need to remember what you learned in the lesson about position, that you must plot your new course on a chart to ensure that it does not navigate you into danger. You need to appreciate that your heading, by which we mean the course you are steering on your compass, is not the same thing as your course over the ground. So you don't simply align your heading to match the bearing to waypoint, because you are trying to offset it to allow for the set and drift. Obviously, the stronger the tide, the more you have to offset. And the process of continually adjusting your heading such that COG and BTW remain in line is only efficient if set and drift remain constant, and very inefficient if the tide is expected to turn on a longer passage, especially in strong tides in a relatively slow vessel. Okay, so much for winging it on the hand-bearing compass or GPS. Let's take a look at the formal method for calculating a course to steer. Imagine we want to navigate from a fix, A, to a destination, B, a distance of approximately 6 miles, and at the same time the tide is setting roughly perpendicular to our required ground track at 2 knots. Start by drawing the ground track from A to and through B, and mark it with 2 arrowheads, which is the symbol for ground track. Now, consider roughly how long it's going to take you to get to B. Is it going to be half an hour? An hour? 2 hours? Keep it simple. It does not have to be exact. In this example, we're going to estimate that our boat speed will be 5 knots, so it's going to take just over an hour, and we'll draw a 1-hour plot. So plot a 2-mile tidal vector way from A and mark it with 3 arrows, the symbol for tide. We'll call the end of the tidal vector point C. We then arc the distance we will travel in an hour, which is rather obviously 5 miles, from point C to intersect the ground track to find point D. Now plot your course to steer CD and measure it with your protractor. In this case, it's 027 degrees true. If you imagine that your boat speed were considerably more, perhaps 6.5 knots, you can see that point D moves further away, and you will not need to offset your course as much to allow for tide. in this case 035 degrees true. And of course, if you are making slow progress, you'd have to offset more, 018 degrees true. Okay, here's a very simple one for you to start with. Plot a course to steer from a fix at the outer end of the transit in and out of Colville to a waypoint at 46 degrees 06 minutes north, 006 degrees west, assuming a speed of 8 knots and the tide setting 296 degrees at 2.3 knots. Give your answer in degrees true. Press the button to reveal the answer. If you've plotted it correctly, you should get 064 degrees true or thereabouts. The distance AB is 8.6 miles. After 1 hour, you will be at point D, and AD is 6.8 miles. Therefore, it will take you over an hour to reach B, the exact time being 8.6 divided by 6.8 equals 1.26 hours, or just under 1 hour and 16 minutes. Sometimes when you need to plot your course to steer on a large-scale chart, you cannot plot a 1-hour diagram. You have to scale it down. For example, if you wanted to calculate a course to steer on RYA chart 4F from a fix at the entrance to Endell Bay, 46 degrees 14.70 minutes north, 005 degrees 47.53 minutes west, to Range Head, South Cardinal Buoy, at a speed of 10 knots, when the tide is setting 220 degrees at 2 knots, you could plot a half-hour diagram. So AC equals 1 mile and CD equals 5 miles, which is how far you'd go in half an hour. You just need to remember that in order to calculate the time it will take you to get to B, you need to double CD to get your speed over the ground in knots. Okay, over to you again. Plot a course to steer from Fairway Buoy outside Roselle Cove to Nera East Cardinal Buoy at a speed of 15 knots, with the tide setting 157 degrees at 1.2 knots, and calculate how long it will take to reach your destination to the nearest minute. Again, press the button to reveal the answer. As I expect you discovered, at 10 knots on this scale, even a half-hour plot is too big to easily fit on the chart. So, in my model answer, I've drawn a 20-minute diagram with AC equaling 0.4 miles and CD 5 miles. You might well have chosen 15 minutes or any other interval, but whatever, you should still have come up with a course to steer of around 222 degrees true and a time of 10 minutes and 46 seconds, so 11 minutes to the nearest minute. Incidentally, just to make sure you are fully cognizant of what's actually going to happen, if you execute this course to steer, how far off your port side will sinker east cardinal buoy be as you come abeam of it? Hopefully you answered approximately 0.3 miles. The point being that your vessel will only ever be on the required ground track. Course to steer plots might run for more than 1 hour, in which case, if the set and drift vary hour by hour, you plot a tidal vector for each hour from your starting position A. Here we have a 2-hour plot with A to C1 representing the first hour's set and drift, and C1 to C2 representing the second hour. C2 to D is then twice your predicted speed. On your RYA chart 3, plot a 2-hour course to steer and calculate the time it will take from the Foxtrot Charlie 3 buoy at the southern end of Dall'Aglio Bay to the Bravo Bravo 5 buoy north-northeast of Holme Point, assuming a speed of 4 knots and a tide of 345 degrees, 0.9 knots for the first hour, and 026 degrees, 1 knot for the second hour. The answer I'm expecting is 313 degrees, or thereabouts. True. 2 hours and 6 minutes. Until now, we've simply calculated a course to steer in degrees true and have ignored variation and leeway. In this example, with variation 7 degrees west, our magnetic course would need to be 320 degrees. Then, with the wind blowing hard from the southwest and perhaps an estimated 10 degrees of leeway, we'd have to steer 10 degrees towards the wind, giving 310 degrees magnetic. Note that when you're applying an adjustment for leeway as part of a course to steer, you add leeway for wind on your starboard side and subtract leeway for wind on your port side. If you get confused by this, draw a wind arrow onto your chart. Then it's pretty obvious what you need to do. Well done. You've completed the lesson. Now go on to complete